In this video, we would like to introduce VIDEX, a disaggregated and extensible virtual index for cloud-native and AI-driven databases. Today's database optimization faces two key challenges. In cloud environments, database optimization direct on production may threaten system stability and data privacy. Meanwhile, integrating AI-driven optimization models remains challenging. This is mainly due to complex database interfaces and programming language differences. VIDEX introduces a three-layer disaggregated architecture. The production database layer manages data and statistical metadata. The VIDEX optimizer layer separates what-if analysis from production databases, enabling virtual indexes and delegates statistical requests to the underlying layer. The VIDEX statistics server layer decouples algorithmic services, thus enabling flexible algorithm integration and AI-specific optimizations. We've implemented VIDEX on MySQL and will demonstrate follows. Easy setup from statistics collection or single file. Accurate what-if analysis with virtual index and Elm explanations. And flexible AI model integration capabilities. Let's connect to both the production and VIDEX optimizer instances. On the left, we have the TPCH database in production, while the VIDEX optimizer on the right is currently empty. Then, let's enter website and input connect information, statistics server, VIDEX optimizer, and online instance. Next, we'll start collecting statistics from the online database. This process typically takes several minutes, so we'll skip ahead to when it's complete. Once finished, we can inspect table metrics such as NDV and histograms. Let's execute show create table on both instances. The only difference is their engine types. VIDEX uses VIDEX, while online uses InnoDB. Now, let's perform a complete index recommendation task using VIDEX. We'll optimize SQL 14 in TPCH, which involves two-table join. Looking at the explain result, we can see a full table scan on the table line item. It's costly. Our website tool provides a tree-style visualization of the query plan, helping users understand how different indexes affect cost across tables. To demonstrate VIDEX's accuracy, let's run the same explain on the online database. As you can see, the online instance produces the same explain result. Line item doesn't use any index, just as VIDEX expected. We provide a comparison feature between online and VIDEX plans, which is very useful for DBAs. We can see VIDEX provides a plan very similar to the online instances. Given that query plans can be complex and long, we employ large language model to provide explanations. The language model will summarize and compare more details. Now, let's see if creating an index on table line item would help. We'll execute creation command in VIDEX. It's very fast, just 0.1 seconds. When we explain this query again, we can see the new index is now used in VIDEX's query plan. We compare VIDEX and online again, and we found VIDEX's cost is much lower, since VIDEX select the new added index. VIDEX believes that the newly added index will be beneficial. Based on this analysis, we'll create the index on the online instance. First, let's execute the query once to see its current performance, about 2.8 seconds. Now, we'll create the index on the online database. Since line item has over 500 million rows, creating this index takes considerable time, about 17 seconds. Once completed, let's compare the query plans again. Now we see both query plans are using the new index. VIDEX's cost closely approximates the online database, demonstrating its accuracy. We run the query on the online again, the execution time drops to less than 0.1 seconds. VIDEX successfully optimized this query. Instead of collecting statistic data from production, we can build VIDEX from a pre-collected statistic file. It's much faster, since we don't need to collect statistic data anymore. Finally, let me demonstrate how to integrate new algorithms into VIDEX. Users can implement VIDEX's Python abstract class. As a very simple example, we can set cardinality estimation to return a tenth of table rows and NDV to return 10. The AI models can also be integrated in similar way. Users can specify the model class when starting the statistics server, and VIDEX will employ new models for subsequent analysis. That's all. Thank you for your attention.